Good morning, students. So let's start with the mesh analysis. But before that, uh, we had one question in Unit 1. I have given that question to you. That question is like this. A wire has a resistance of 3 ohm. Wire is being stretched to some extent in such a way that diameter of wire has been halved. And now the question is, what will be the resistance of the wire after being stretched in such a way that it has the diameter is half. Okay, so here this is the actual scenario. This is the old wire and this is the new wire, you can say. But the main thing is that here the information given is wire is being stretched. So no new material is added, just the same wire is stretched. So volume of the wire in both the cases would be same. So here the and the volume of the new wire would be same. Why? Because I am stretching this piece of wire and extending its length. So whenever I stretch something, the diameter or the thickness of the material would be decreasing. So here the diameter is decreasing. So this is the case. The earlier length of the wire was L. Now it has been extended to new length, that is small l, and the diameter that was D is now a new diameter is small d, which is equal to original by 2. So original was capital D divided by 2. So this is the case. Now if I consider the volume of the to be same, I can write this equation. The volume is length into diameter. If I consider a cylinder, a solid cylinder, so that is volume length into the cross section area of this wire. So this is the cross section area, pi d square by 4 into L, and I'm equating it with the new wire volume, that is small l into pi d square by 4. But here I will consider small d. Then I will replace this d by 2, and what I'll get is new length of the wire from solving this equations. So I will get the new length is 4 times the old wire length. Okay, so I have the new information now. Now using this new information, I can get the new resistance of this wire. Okay, now we know that R is equal to rho L by A. Now from this equation, for old wire, what I can write is R is 3 ohm, rho L pi d square by 4, that is the cross section area. So I can get my value of rho that I will replace in the case of new wire. Now the same way for new wire, my resistance R is equal to rho L by A, but here I'll consider a small a because the diameter is different. So rho L by pi d square by 4, now I'll replace this L by 4L, okay, because we just found out L is equal to 4L, the new length of wire is 4 times the old length, and we know the diameter is half compared to the old wire. So I can replace this d by 2. So replacing that, I can get the equation 3 pi d square by 4L into this L is replaced by 4L. Pi d square, put a value of d, that is equal to capital D by 2. So pi by 4 into d square by 4. Okay, I'll cancel out the terms that are common in denominator and numerator. So I'll get 3 divided by, so numerator of numerator is 4 into 4, that is 16. So numerator of numerator will go into sorry, denominator of denominator will go into numerator. So I'll get 3 into 16, that is 48. So my final answer is 48 ohm. It is the resistance of this new wire. This is how you can solve this. I'll share this in material section. You can look into that whenever required. Okay. Now apart from this, if you have any doubts, you can raise the doubt. If you have any question apart from this, you can ask it. Otherwise, we'll move ahead with the mesh analysis. Yeah, any questions? Okay, so I'll move ahead with the mesh analysis. So earlier class, we have seen the basics of mesh analysis, like how to perform the mesh analysis, how you can use a KVL in mesh analysis, and how you can get the final currents of your loop. So first task in the mesh analysis was identify the elementary mesh. So here, if you consider this example, this is my first mesh.
Sir, screen not visible, sir.
Just a moment. Yeah. Okay, so now here in mesh analysis, we will first find out the elementary meshes. So in this example, we have this mesh. This is the second one, third one, and fourth one. Then the second step is assign the mesh current. Generally, we'll always assign the mesh current in clockwise direction. So you will see in all these loops, I'll assign the direction of the current like this. Okay, so the second step is to assign mesh current. Third step was to apply the KVL and write down the equation of the voltage in this loop or in this mesh. Okay, so for an example, for this, let's see that example later on. So I'll write a KVL and then I'll solve the resulting equations. Like for this case, I'll get 4 equations. For one for this mesh, second, third, and fourth. For 4 different mesh, 4 different equations, and I'll solve that 4 equations, and then I get my answer. And this equation can help you out to find out the number of meshes available in the circuit. So L is the number of meshes, B is the number of branch, and N is the number of node. How to find out number of branches? So whenever you see an element like this, you will consider this as a branch. So this is my first branch, this is my second branch, third branch, fourth branch, fifth, this is sixth, seventh, 8th, 9th, and 10th. So I'll have 10 branches over here. Number of nodes. So this is my node. So let us say this is node 1, node 2, node 3, node 4, node 5. This is one more, node 6. This is node 7. This is node 8. I'll have 8 nodes. So number of sorry, I have done something wrong here. There should be not 10. Okay, so see, these two are the same thing. So I have total 7 nodes here. So 10 and 7. So 10 minus 7 plus 1, that is 4. So we have 4 meshes here, as we have seen, first, second, third, and fourth. 4 meshes. Now we'll consider an example. So here in this example, we'll go with this clockwise direction of current, and we'll try to write down the equation for the KVL. Now we'll go with a very basic rule. Whenever there is an element, let us say this is an element, whether being a voltage source or a resistor, if I travel from negative to positive, if I travel from negative to positive, I'll consider the sign here to be positive, or I can say this is rise in voltage. And whenever I am going positive to negative across any element, in that case I'll get this as a negative, or I can say voltage drop. Don't look at this equation right now, I'll simplify that. Write this equation. Okay, so let us assume here we'll start from this point. I'm going from this direction to this direction, that is minus to plus. So minus to plus is rise in voltage, so I'll get plus for that. So here let us write down equation is Vs2. As this voltage source would be positive, I have to consider it positive, so I'll just write Vs2. Then I will move ahead in this direction across this resistive element R1. So here I'll see a positive and a negative. So I'm going from positive to negative. So positive to negative is voltage drop. So I'll write minus V1. And further you can break it down and you can write it like I1 R1. I1 is the current flowing through this element and R1 is the resistance, so I can write minus I1 R1. Then I'll move ahead, I'll come across this branch. Now here, if you look at this branch, here two type of potential difference would be occurring. The first potential difference or first voltage is appearing due to the current I1 that is flowing in this direction, so I'll write positive negative polarity, and the other current is appearing in this opposite direction, so I can write down one more polarity, that is positive negative. So for this two different current flowing through this branch, I have two different potential difference. So let us write it down, both of them. So first I'll write, see here I have a positive polarity, so I will write minus I1, and this is resistance number 7. I'll write minus I1 R7. Again, I have one more voltage drop over here. I have one more voltage drop over here, and I am still going through this direction. I am writing the KVL. I am going in this direction. So now for this voltage drop occurring due to I2, if you see the polarity is minus 2 plus, and minus 2 plus is rise in the voltage. So I will write minus I1 R7 plus I2 R7. Okay. Then I'll move ahead in this direction. Move ahead in this direction. Again minus 2 plus. So that would be just okay. Just for the sake of simplicity, we will not go with this. Will not go with this elementary positive negative. This polarity is given based on some other assumptions. But if current is flowing in this direction, the positive would appear over here and negative would appear over here. So actually this would be a positive. So it would be plus, that means plus 2 minus is voltage drop. So I'll write I1 R5 minus I1 R5, and due to I3 is flowing in this direction. So I'll write plus I3 R5. Okay. And then I'll get this kind of equations. We'll directly see this in example, like how to solve this equations. Then I'll get this equation. I will simplify. I'll take I1, I2 and I3 common over here. So I'll get this kind of equation with I1, I2, I3 elements. I'll take all the voltage source opposite on, or you can say on right hand side. I will take all the voltages, and from this equations I can write down this kind of matrix, and using or solving this matrix we'll get I1, I2, I3 and I4 values. Okay, what we will have in actual example, the value of resistance will be provided to us, the value of voltage sources would be available with us, but the current would not be available with us, and we are actually going to find out the current using mesh analysis. So we'll finding I1, I2, I3 and I4. So how to write down this matrix? So here you can see R1, R5, R7 multiplied with I1. So I will write first element as R1, R5, R7, and here in the second matrix, this is a column matrix. Here I will write I1. Okay, so if I simplify this too, so I will directly multiply it with this. Same way minus I2 R7. So I will consider minus R7 and I will put plus I2 over here. So I will consider minus I7, R7, I2. So if I solve this, I will get I2 R7. Same way R5 I3. So minus R5 here, I3 over here. Now as I know there are 4 currents or 4 meshes available, but the fourth element is not present in this case. I4 is not available. So I have to put a 0 and I4 over here. So if I simplify it, this term will vanish. Same way for the other meshes I have to write this equations, and finally I'll get this kind of matrix. This is nothing but Ri equal to V. Now solving this equation, this would be an L by L symmetry. The resistive R matrix is L by L symmetry. The matrix I would be 1 by L vector, and V is again the known voltages would be 1 by L. So solving this equations, you can easily find out the value of I1, I2, I3 and I4. Okay. Now how to solve this? So to solve this, you can use the Cramer's rule. Suppose this is the scenario. A11, X1, X2 and X3 are the three unknowns. Okay, so to find out X1, X2 and X3, you can use the Cramer's rule like this. So I'll prepare equation like this. Okay, A11, X2 and A13, X3 was the equation. This is the equation. So I have taken out this A1, A2, A3 and X1, X2, X3 in the vector matrix. Now to value for X2 and X3, I have to find out the determinant of the this A, B and X. So I have declared this as A, this is my A, this is my B and this is my X. X is the unknown. I have to find out, I want to find out X. So X1 would be D1 by D, X2 would be D2 by D and X3 would be D3 by D. But what is D1, D2, D3 and D is the question. So D1, D2 and D3 are nothing but D is the matrix A itself, determinant of A. See, this is well matrix A. If I find out the determinant of A, I'll get the D. What is D1? D1 is nothing but A. See how to write this D1. For D1, I'll remove this line and I will replace this with this line. So I'll write like this: B1, B2, B1, then B2, B3, then here A12, A22, A32, A13, A23 and A33. And if I find out the determinant of this matrix, then it is D1. Same way for D2, I will remove this line. For D2, I will remove this line. I will replace this with B. So B1, B2, B3 here. A11, A13 will be as it is. This two lines would be as it is. But I will replace this second element. Same way for D3, I will replace this one. And I'll find out all the determinants. So this replacing this will get me D1, replacing the second element will get me D2, and replacing third will get me D3. And X1 is nothing but D1 by D2, X2 is D2 by D, and X3 is D3 by D. So this is D1, D2 and D3. You can see B1, B2, B3 over here. The other two are as it is. D2, B1, B2, B3 in center line, other two are as it is, and D3. The third element would be replacing by B. Now solving this equation, you can easily get what is the answer. Okay. Now let us see an example of mesh analysis. So here the question is, determine the mesh current I1, I2 and I3 for the network shown below. See, this is the network. Okay. So let us write down the equations for this network first. Let us write down the equation. I'll take this figure in this notebook and we'll write the equations. Now see here, if you consider this, these three meshes are available in this network. This is my mesh 1, this is my mesh 2 and this is my mesh 3. Three meshes are available in this network. So for these three meshes, I am going to write down three different equations. Okay, let us see first. For first mesh, the current is I1 flowing in clockwise direction. So I write the equation. I'll begin from this point. Okay. Before that, let's have some polarity. Okay, so here for this 10 ohm resistor, let's have polarity. So polarity would be plus and minus for current I1. Okay, I am going I1 like this. This is my I1. Again, whenever I come here, my polarity would be like this. Whenever current is flowing across the resistor, the first terminal where the current enters would be positive and where the current exists is negative. Okay, so plus minus over here, plus over here, and minus over here. So this polarity is due to current I1. Now, what if the polarity with the current I2? So let us see that polarity. So I am drawing it with green color. So this is my current I2. So here the polarity is like this. So this would be positive, this would be negative. Again, this would be positive, this would be negative. Voltage source, we cannot decide the polarity of voltage source. It is predefined. Okay. And for this element, it would be positive over here and negative over here. Same way for the branch 3. Let us take one more color. So this is my I3. So positive over here, negative over here, positive over here, negative over here. Okay. Now I have given all the polarities. Now I can start to write the equation. Okay. Let us write down the first equation for mesh 1. So equation for mesh 1. I'll write it over here. So I'll begin from this point. I'll begin from this point. I'm moving in this direction. Negative to positive is plus. So I'll write 50. As that is a voltage source, I will write just 50. Okay. Then I'll come across my first element, that is 10 ohm resistor. So I'll write down minus 10 into I1. Why? Because for I1, the 10 ohm resistor creates a voltage drop for current I1. Same way, I'll move ahead with the resistor of 5 ohm. For that, I'll write minus 5I1. Now, along with this current here, along with this current, there is one more current flowing in opposite direction, and due to that the opposite polarity appears over there. So for that second voltage drop across this same 5 ohm resistor, I'll write one more term, that is minus 5I1 plus 5I2, because here the polarity is different. So here I'll write plus 5I2. Okay, move ahead with the 3 ohm resistor. So I'll get minus 3I1 plus 3I3 is equal to 0. So this is my first equation. Now if I simplify this equation, what I'll get, my final equation is 10 plus 5 plus 3, 18I1 let's write down minus 18I1 plus 5I2 plus 3I3 is equal to minus 50. Okay, this is my equation 1. Or else you can write it like 18I1 minus 5I2 minus 3 equal to 50. You can write it in both the way, and for both the cases the answer would be same. Now same way for the loop 2. For loop 2 I will write equation again. I'll start with this point. I will start from this point here. So I am going across the 2 ohm resistor first. Current flowing is I2, so I'll write minus 2I2. Then I am coming across the potential or voltage source, but here you can see I am going from positive to negative, so I'll get minus 10. Then I'll move ahead with the 1 ohm resistor, so I'll get minus I2 plus I3. Then I'll get minus 5I2 plus 5I1 is equal to 0. Again, I'll simplify this equation. So here I'll get 5I1 minus 8I2 and I3 is equal to 10. This is my equation 2. And same way for the third branch, I'll write equation that is minus I3 plus I2 minus 5 minus 3I3 and plus 3I1 is equal to 0. So simplifying this, I'll get 3I1 minus not minus plus I2 minus 4I3 is equal to 5. This is my equation 3. Now from 1 to 3, if I try to write down the RIV matrix, this matrix RI is equal to V. So here my R would be minus 18 plus 5 and 3 minus 2, sorry, not minus 2, this would be 5, then minus 8, and 1. And for the last equation, that would be 3, 1 and minus 4. Okay. And what would be my V? V is minus 50, 10 and 5. Now using Cramer's equation, I can solve this equation, and solving this equation will get me my final answer. But this is how you can write the equation. Okay. Now let us see here what they have done. So here you can see 50 minus 10 I1 minus 5. Now you can write it like this. This would be much more easier for you. Take this element, write two separate voltage drop for this element rather than doing this, because I1 minus I2, sometimes it will become I2 minus I1 and it will create a conflict. So rather than that, take two different voltage drops across this element, consider the polarity of each, and according to that write down the KVL. Okay, but final equation would be same. See here the equation is 50 equal to I2 18 I1 minus 5 I2 minus 3 I3, but what we get here is the inverted equation, minus 18 plus 5 plus 3 equal to minus 15, but the solution would be same at the end of the example. Same way, minus 10 minus 5 plus minus I3, so sorry, minus plus 5 minus 8 I2, see, plus 5 I1 minus 8 I2 plus I3, that what we get is equal to 10. So there is only the issue of the polarity, like what we have taken on left hand side, that they have taken on right hand side. That's why we created this negative positive issue, but at the end we'll get the answer, and that would be the same, minus 5 minus 3 minus 1 plus 4. So what we get is 3 plus 1 minus 4 equal to 5. And then we can write this equation, 15 minus 10 minus 5, and this is my R. So what we have got is the same as this one, but only the positive becomes negative in that case. So 18 minus 5 minus 3. So we have minus 8, 5 and 3. Then minus 5, 8 minus 1. So 5 minus 8 and 1. 3 1, sorry, minus 3, minus 1, 4. Instead of that, we have 3, 1, minus 4. And on this side, 50 minus 10, 5, minus 5. Instead, we have minus 50, 10, 5. But solving this both with the same Cramer's rule, you will get the same answer. So what I am getting here is determinant of each. So first I'll get this delta R, determinant of this matrix. So I hope you know how to find out the determinant. Let me give you an example for this one. How to find out the determinant. So here I'll get 18, 8 into 4 minus 1 into minus 1. Okay. So I'll take this first element, I'll cross multiply this 2, minus sign in between, and I'll multiply this term with this term. Same way, minus, the second term would be default minus. So minus 5 into minus 5 into 4. These two are multiplied, and then I'll get minus 3 into minus 1. So here for the second term, this term, I'll take this 2. So minus 5, 5 into 4 and 3 into 1, but along with the sign. So minus 5 into 4, that is minus 20. Minus 3 into minus 1, that is plus 3. But there would be in between minus. So this is the other term, and the third term is minus 3. Okay, there will be plus sign ahead, but minus 3 into minus 5 into minus 1 minus 8 into minus 3. So solving this equation, I'll get 356 ohms. You can say I'll get 356 ohms. Solving this entire matrix. Same way, I'll get delta R1 and delta R2 and delta R3. I'll get this other 3. But how to get this delta R1? I'll replace this 18 minus 5 and minus 3 with V1, V2 and V3. So what is V1, V2, V3? 50 minus 10 and minus 5. Okay. So I'll get 1175. I'll get 355 and 525. Delta R1, delta R2 and delta R3. Now current I1 would be delta R1 divided by delta R2. So that is 3.3 amperes, current I2 and I3. So this is my final answer, and this is the current flowing through I1, I2, I3, 3 different meshes. So here I1, I2 and I3 values we finally have like this. So I1, I2 and I3. Okay. Now I have one more example, and this example you are going to calculate this example and you will give me the answer. I'll get you 5-10 minutes to solve this. So start solving this example. If you have any query, you can ask me immediately. If you have any query, you can raise the query. Otherwise, you can start solving this example. Keep that in mind. Here there is a one more voltage source available in between the branch.
Well, I get the answer.
Yeah, please go ahead. What is the value of I1?
I1 is equal to 2.11
Just a minute. 2.11 ampere. Then
I2 is equal to 4 ampere,
4 ampere. Okay.
and I3 is equal to 2 ampere.
2 ampere. Anyone else? Anyone else?
Sir, I am getting the same value of I3. I1
In the same value.
is same as I1. 1.13. I'm getting the same.
1.13. Then the second I2 and I3.
Sir, I2 is not proper. It is inappropriate.
But go
Sir,
ahead.
it is coming negative.
It can be negative. No issue in that.
Okay, sir. It will be 17/12, sir.
17/12. Can you get it mean decimal like with point?
Okay, sir. 1 minute. 1.41.
1.41 ampere minus.
Yes, sir.
Okay. And I3.
Sir, similar to I1. 1.13 ampere.
1.13 ampere. Okay. Whenever you get a negative answer, it is not wrong. Suppose find this loop. If I get a negative answer, minus
Direction will be reversed.
ampere, that means the direction I have chosen or I have assumed, this is my assumed direction of the current, is actually in opposite direction. So actually the current is flowing in anti-clockwise direction like this in actual scenario, but for the calculation we were not knowing this earlier, so we have taken an assumption, and based on that assumption we have calculated the answer, and that's why the answer is negative. So the negative answers are possible. It is not wrong at all. The negative just represent a negative current or a current in the reverse direction compared to your assumed direction of the current. So for this case, the current would be in opposite direction. Okay, so let's
So,
see.
sir,
Huh, go ahead.
exact negative value of current, so it is right.
Whenever you get any answer, there is only one solution to each and every problem. With whichever equation you can solve that, but you will always end up with the same value. For an example, here the matrix over here, uh, the matrix I get and the represented in PPT, that two are different. Okay, but if I solve this with the Cramer's rule and I'll solve my equation, this one with the Cramer's rule, I'll get the same values of this delta R1, R2 and R3. If I solve my, then also I'll get this 355, 1175 and 355 and 525. If you don't believe me, let's check that whether it's true or not. Let's say I am calculating delta R. Okay, I am calculating delta R. So for delta R, here my delta R is minus 18 into 8 into 4, 32, minus 1, minus 5 into 5, 4, 20, 3 and plus 3, 5 plus 24. Okay, now just look at this. I'm just calculating this. 32 minus 1 is 31 into 18. That is 558. So I'm writing 558 over here. Minus 558. Then minus 20 minus 3 minus 23 multiply with minus 5. So 23 into 5. It is 115, but this 115 would be positive. So I'll write plus 115. So here it would be plus 115 and plus 24 plus 5. 24 plus 5 is 29, multiplied with 3, I'll get 87. Okay. Now if I solve this, I'll get 558 minus 115, sorry, it would be minus 87, 356. But what I get is negative 356. See, the answer is still same. Only the issue is plus becomes minus. But as this has changed the sign, according to that, this matrices will also change the sign in my case. And at the end, I'll get the same answer. Okay, but the numeric value is same. Only the sign issue is that. But if I solve it for the other one, then I'll remove that sign issue as well, and I'll get the same I1, I2, and I3 values. So do not worry about it. Whether you write equation in like LHS, RHS, if you misplace that and plus become minus, in that case also you get the same answer, provided that you have written these equations correct. If this equation is wrong, then you'll get different answers. So for this example, my equation become like this. See, I'm going from here to here, so this would become plus 7 minus I1 plus I2. I'll go ahead. See, there is plus 2 minus, so minus 6. Then see, this would be a minus 6. In case of this current I1 loop, I'll get a minus 6 voltage because there is a voltage source. I'm going from plus to minus, so I'll get minus 6. Then I'll go ahead, this minus 2 I1 and plus 2 I3. Okay, so this is my final equation. Same way for the other two loop, these are the equations. And at the end, this is my matrix. Anyone who have different than this matrix will get a different answer. Like if there is a sign issue, like is minus
So sign issue.
Sign issue is correct. Sign issue is not a big problem. But if someone is getting instead of 3, if you are getting 2, then that is an issue. Otherwise, sign issue is there. If you take on right side or left side, depends on that, the sign issue will be there. But after solving this 4 value will be like this. Numerical value would be 39 for delta R. Delta R1 will be 117. R2 would be 78 and R3 would be 117. And at the end, I'll get this value. 3 ampere, 2 ampere and 3 ampere is my final answer. Now what you were getting is, okay, someone was getting 1.13 minus 1.14 and 1.13 that are wrong. 2.11, 4 and 2 that are also wrong. The actual correct answer are this. Who was having the sign issue?
Sir, both questions are different.
No, that are the same question. So this is the question. 3 minus 1 minus 2. Okay, so the matrix is 3 minus 1 minus 2. 3 minus 1 minus 2. And I am solving this. It's the same question. Okay, what is your matrix? Your matrix looks like this, exactly like this, or it is inverted matrix, like minus will become plus.
So minus becomes plus and answer is also minus 3 minus 2 minus 3.
Minus 3 minus 2.
Minus 3 ampere.
It is not possible. What is your answer? This 39 become minus 39.
Yes, sir.
Then 117.
Minus.
Minus 117. So minus 117 divided by minus 39.
Oh, sir.
Plus 3. So if both are minus, you can take it as plus. So there will be no issue. Otherwise, you get 3, 2, 3. Okay. So this is how you can solve this. I'll share this PPT. Just go it through once again and see where you are wrong. Otherwise, we are running out of time. It is 11:14 already. and we'll start with nodal analysis in next lecture. Okay, I'll share this PPT today. I'll remove this nodal analysis part, or I'll just share this mesh analysis question, and you can solve this.
Constant PPT.
Sorry,
So we mobile access, not PPT.
I'll share a PDF.
Yes.
I'll convert it in PDF and I'll share the PDF. Okay,
Yes, sir.
so you can access, you can evaluate your answers along with that. Otherwise, we are done here. You can leave the class if you want. If you have any query, you can raise the question.
Okay, sir.